begin today with a warm-up on the stuff that we did yesterday. And so the key thing I want you to remember is label the information that you're given. So I'm going to make sure that I highlight and teach just how I would in class. This will also be posted on my Edline. So tonight, if you want to go back and re-watch or make sure you get all the notes written down, feel free to do so. We're going to begin by determining how these different triangles are congruent. The idea being that just from the visual aid, you can make a connection between two different triangles. So what I'd like for you to first notice is that we are given one side. And I'm going to label this as my side S. And then we need to notice a few more specific things about this picture. One being these arrows. Does anybody know what those arrows mean? There was either a very long pause or somebody shouted, "Parallel lines! Yay!" Alright, that means parallel. And being parallel, we know some special properties, specifically with regards to alternate interior, exterior, consecutive interior, and corresponding angles. I'm not going into a lot of detail about it right this minute, but hopefully you can remember that when cut by a transversal, which I'm going to notify right here, that's your transversal, we can quickly see that angle I is congruent to angle E. And the reason for that, in case you don't notice, is the alternate interior angle theorem. So, I'm going to label my A and my A, and then I know, because I've already highlighted it, that you are all screaming at my computer that you see the reflexive property. Okay? The reflexive property tells me that I, Mrs. Himmler, am Mrs. Himmler. That segment IE is congruent to segment IE. So, we have a side, angle, side, which means these two triangles are congruent. What two triangles would that be? Well, hopefully in that amount of time you thought about something and you remembered that order mattered. So I'm going to start with B, and B goes with K. From B we went to I, and from I to E. Okay, from K we went to E and then I. Order matters, guys. Don't forget. Now, you're probably thinking, why did you start with the hard one? Guys, we got to get your brain moving. This next one better be real easy. Alright? What do you see off the top? I see a side. So, side BC is congruent to what other side? Right, side ED because of the same tick mark. And then we go in order. So next you see these angles. Angle C is congruent to angle D. And one more, same tick mark. So in a much easier fashion, we still have SAS. Side, angle, side. With that said, please remember to make sure you go in the appropriate order when you're saying which angles are congruent. Last but not least, you see this very strange picture, and we're going to actually start looking at what our most obvious feature is. You see this type of triangle, and you're going to look for something specific. What do you think it is? Did you say right triangle? Maybe not, because you didn't want to talk to a TV, but hey, it's okay. I'm right here. Alright, we've got this right angle, which means we first want to look for hypotenuse leg. Right here, I do see this leg that we've been given. And what does hypotenuse mean? Hypotenuse does actually mean the longest side, or the side across from your right angles. And so in this case, once again, using that Strain's reflexive property, we have that BD is congruent to BD. So this triangle is hypotenuse leg. And we would say that it's triangle BDA is congruent to triangle DBC. Order matters. DBC, BDA. Now, if you struggled with that, make sure you look at homework from last night and do a little more practice. But I'm going to go ahead and move on to our notes for today. And the key thing about today, and I guess I'll give you a minute for those of you who want to write that down, and remember you can go pause the video at home tonight, is we're going to discuss the topic of proving triangle congruence, meaning that the 6 examples I have for you today are all proofs. Alright, now, okay, you stop that moaning. I understand that it's not your favorite time of the day, but oh, look, one of the answers is still hidden in there. I'm going to pause. Oh. Or I'm not going to pause. I meant to pause. So as I was saying, just today basically we're going to do a lot of examples. I'm going to work through these first 3 with you. And the first 3 are really nice because I've decided to give you a word bank. So the way that we start is by notifying what our givens are. So we're told that AT is congruent to HT. And I want to mark that on my picture. Side AT is congruent to side HT. So both with the tick marks and with the letters. Then what comes next? It says that MA, so I'm going to go ahead and do my tick marks first this time. MA is congruent to MH. And another thing you could do instead of the tick marks is on that EOC, when you're allowed to use highlighters, go ahead and color coordinate everything that you're given so order is easily identified. So in the proof below, you see our givens are stated. What else do you think we need? Right now we've got side, side, and we're not allowed to have any dirty words. So what other piece of information do you see that could make this word? Do you see the reflexive property right here? That side MT is congruent to side MT. It's okay if you didn't, but that's a very big property that we need to make sure we can identify. And when you say something is equal to itself, it's the reflexive property, in this case of congruence, because that symbol is what we're talking about. We're talking about a length, a leg, rather than the actual measure. And to finish this off, hopefully you real quickly see that it is side, 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 because that's what we have. Side, 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 side. Alright, easy peasy lemon squeezy. Let's move to example number 2. Once again, we're going to complete the following proof. This one is example 2 on your notes sheet. And we're going to begin with what we're given. So we're told that AC bisects angle B and angle BAD. So let's mark that. AC, this line right here, bisects BCD, and let me get a different color, BAD. Now, you're probably thinking right now, I know what bisects means, and good for you. Hopefully you were thinking that it means cut in half. And what are we cutting in half? What shape did we make? Does that look like an angle to you? It looks like an angle to me. So what we're going to do is we're going to take BCD first. And BCD cuts into angle BCA, which is congruent to angle DCA. And I've tried to say the word angle enough times that you know this is an angle bisector. Okay, it cuts and makes multiple angles. That's how we know. The next thing should be very straightforward as well. Since we're bisecting again, it means we're cutting in half. Only this time we're cutting in half the blue piece. So now we're going to have angle BAC is congruent to angle DAC. And that reason, once again, is the definition of angle bisector. Alright, so please remember, if you're struggling with this, if you don't see that, my notes will be on Edline, and you can always come in for tutoring tomorrow morning. The last piece of information we actually highlighted at the very beginning. Right now, if I go back and label my picture, we've got an angle, an angle, an angle, and an angle, and we need the piece in the middle. Alright? So we've got, I'm just going to focus on triangle BAC. We've got these two angles. What is in the middle? Do you see what I see? The property that I've told you already, really important, is that reflexive property. We know that segment AC is congruent to segment AC. And so because it's like looking in a mirror and seeing your own reflection, we call it the reflexive property, meaning that if you know something's true and you have it again, it's still true. What I want to identify, though, is the triangles we were looking for. Triangle ABC and triangle ADC. What property, what type of congruence is on that triangle? Remember, order matters. Find what's on the inside, what's in the middle. In the middle I see S. So I know that I'm down to either side, 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 angle, or side, side, angle. And one of those is illegal. You better know real fast that we don't need any donkeys in our math problems. So, and that leaves only angle, side, angle, because, well, side, side, side would mean all sides, and we clearly have angles. So, angle, side, angle, order matters, okay? Very important that you make sure when you're dealing with your properties that you're given, when you have that angle, side, angle, you don't say angle, angle, side instead, because you go the wrong way. Okay? Moving on to the third example, and it's the last example with a word bank. So what I'm gonna do is, personally, I'm just gonna set my timer, and you'll hear it go off for about 1 minute of real time for you to try this problem on your own. When you go home, if I was to do this in the evening, I would just ask you to pause, but I'm gonna go ahead and set my pinball timer for 1 minute. Okay, that timer tells us that you've had 1 minute. In that time, hopefully you discussed with a partner or worked to figure out the answers. I'm going to fill it in real quick. We know that bisects, that first key piece of important information. Oh, sorry, having a glitch. We know that bisects means cuts in half. So KLM is now cut so that these pieces are congruent thanks to JL. So I can say that angle KLJ is congruent to angle MLJ. And that property would be the angle bisector property, followed by a given that you saw in your picture, leaving the most beautiful thing, that JL, because of that reflexive property, is congruent to itself. So I'm going to plug in that reflexive property. I'm going to go label my picture with an angle, and a side, which follows on the other one as well. Angle, side, and that should be the property that you choose. Alright, so not too shabby. Its proofs as usual. What's going to happen is I'm going to go ahead and do a couple of these examples with you, and then I'm going to give you time for homework. Once again, I'm really sorry that I'm not there today, but feel free during this video, if you have a question, to tweet me. You know that I've always got access to that, and I'm willing to work with you. I'm going to begin with the givens. Given that T is the midpoint of QS, so here's QS and here's T, that means that we, one more time, cut in half. What? So QT, segment, QT, will be congruent to segment TS, and hopefully you don't try to overcomplicate it and you just say the definition of midpoint. Alright, we're given our next piece of information that I hadn't looked at yet, but it came straight in our proof, and we see this funny symbol. Who remembers that funny symbol? There's the first letter, there's the second letter, and I'll go ahead and spell it out for you. It's perpendicular. Yay! Perpendicular means something very special, always and forever. It will make a right angle. So we now know that angle QTR is 90 degrees. And that is the definition of perpendicular. And we know that angle STR is 90 degrees. And I know, ladies and gentlemen, it's silly, but because of that, we can say that QTR, angle QTR, is congruent to angle STR, because right angles are congruent, or the right angle congruence theorem. Okay? Leaving your favorite property in the dust. Da 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 da. I hope you saw real quickly that TR is in fact congruent to itself by that reflexive property. And something I could have done along the way, but I like to do at the end, is go back through and see what information I found. So I've got two sides right here from that midpoint. QT is congruent to TS. I've got that QTR is congruent to STR, which means that's an angle, and then I've got my last side. So we finish this up with side, angle, side. What? Professional work. I'm so proud. Don't be too upset if you struggled with that, especially right here. Alright? Just make sure you understand, and that if you were to see a multiple choice question, you might be able to eliminate other answers that didn't make sense. The next example is example number 5, and I like this example because it brings up the point of identifying what you're given. So I want to take this one piece at a time, starting with triangle VWX, which is a right triangle, and I want to go find that triangle. So I'm going to highlight it green, and VWX. So that's actually that big triangle right there, and that's important that you know what you're working with. On the other hand, I'm going to grab my red pen again, and we've got triangle YXW, which is also a right triangle, and I'm going to highlight that in blue. So YXW. Now you know what you're working with, and remember, we have one favorite property that when we see right triangles that we want to check out. Do you remember what that property is? Hypotenuse leg. So let's continue to see what we were given. The last piece is that VW is congruent to YX. And so I'm going to go label that VW. Oh, it's already labeled. It's congruent to YX. And what else do I know? Well, as mentioned earlier, and this can be difficult to see, the hypotenuse is the side opposite the right angle. And so for both triangles, they share this hypotenuse. Now, if we're sharing that hypotenuse, can't we say that WX is congruent to itself? I hope so, based upon the reflexive property. And since we have a hypotenuse and a leg, HL is sufficient. Now, I want to go back to the original thing that I told you. Make note of what you're given. You saw right triangles, you need to look at the triangles you were provided. In the last example, and quite possibly one of the ones that can be the most difficult to see, I want to once again start with what we're given. So we know that PQ is parallel to SR. And that was noted by these little arrows right here. From the very first problem in the warm-up, I was preparing you for this problem. Don't you see, and if you don't, could you see that we have a transversal right here? Given that transversal, and our box has already been created, we have special properties for angles, such as this one and this one. Oh, okay, we know that they're congruent because they're alternate interior angles. So angle QPR is congruent to angle SRP, because if two lines are parallel, then alternate interior angles are congruent. Say that again. If two lines are parallel, then alternate interior angles are congruent. Alright, that's how it would be worded in that multiple choice question that you're going to see, and probably on your test. From there, we go back to our givens, and we are told that the measure of angle S equals 90 degrees, and that the measure of angle Q equals 90 degrees. And because you're brilliant, what might you tell me? That they're equal. Very good. So the measure of angle S is congruent to the measure of angle Q. But why? Why are those, but as I mentioned, why? Why are those congruent? And ladies and gentlemen, it's your original favorite property, where if you cut out that middleman, it's the transitive property of congruence. And since the measures are congruent, that does imply that the angles are congruent. Definition of congruence. And then what? What is it that we've done? We have that these angles are congruent. We have that these angles are congruent. Oh, you see it. I know you see it. One more time. not PQ, let me get my letters straight. PR is congruent to itself by the reflexive property of congruence. And still I can't spell. By the reflexive property of congruence. And so make sure you go in the right order. We already discussed that this is a side, and we have an angle, and we have an angle. So what is our order? So what was in the middle? That's how a good place to start. And then go to the left or the right of that. I see side, angle, angle, which we can translate into angle, angle, side. Alright, that's all the notes we have for today. I hope that was helpful. If you need to get a computer from the back of the room to look at my notes on Edline, all of these answers are on there. And you're going to have approximately 20 minutes to work on your homework. During that time, I expect you to use your notes. Think about all the things we discussed today as you prepare for your quiz tomorrow. Don't fret, it's not too bad. Alright, so your practice looks like this, only you have all your lines. Get started, and thanks for rocking. I will see y'all tomorrow. Bye.